Hi, I'm here to talk about lunar caves, but more importantly, what we can do with the lunar cave once we find one. Oh, excuse me. So this is my image of the future of humans on the surface of the moon. This is showing a rocket launch from the surface to somewhere else, possibly Mars, another moon in our solar system, or even beyond. And you notice this looks a lot different from what we're used to seeing in images like this. This is from Russia in 1955, an image from a children's book in the Cold War. So basically, we used to think we could just fly machines, fly parts of bases to the moon, and set up there. There's even a monorail in this. It looks a bit silly now. And it turns out this wasn't very feasible. So first of all, it's very, very expensive to fly something this big to the moon. And more importantly, the moon doesn't have an atmosphere like we have on Earth. So the temperature on the surface of the moon can be as hot as plus 200 Celsius or as cold as minus 200, almost. And even worse, the moon doesn't have an atmosphere that protects us from radiation. So it's actually quite a dangerous environment. This image is from 1989, from NASA. This is a little more realistic. This is some kind of inflatable structure that would be easier to get to the moon. But I'm not convinced that this has the kind of strength to withstand the temperature and radiation. And in fact, this idea never really happened. But if we find a cave on the surface of the moon, all those problems are taken care of. A deep cave would protect us from radiation and would have much better temperature environment, much easier to build a habitat in. And we have these on Earth. This one is from Hawaii. And basically, these form when a lava flow forms a crust over top, and then the lava flow stops. And at that point, the lava inside the cave drains, leaving this perfectly round shape and a nice strong shape as well. Now, we know that there has been volcanic activity on the moon. And so we hope to find these on the moon as well. Unfortunately, they're very easy to find. So this is a lunar tube skylight. This particular one is also from America. And basically, the point is, we can see these from above quite easily. So if these are on the moon, we should be able to see them. And actually, we have. In the last few years, we've had very successful missions from the Japanese and American space agencies. So this image is from the American lunar orbiter. And all 5 of these images are of the same feature. So I think it's very convincing that this is some kind of skylight into a cave and not just a crater. The bottom image especially, I think this is very convincing that there's something there besides just a small hole. And once we've confirmed one of these exists, the next step is building it into some kind of livable structure. And I mentioned the temperature environment is much better in one of these caves. Based on modeling and experiments from the Apollo era, actually we know the temperature is like minus 20 Celsius or minus 40 Celsius. So that's much, much easier than minus 200 or plus 200. And we actually have the technology already to easily deploy a base inside one of these. So the left-hand image here is from a 90s NASA project. This ultimately didn't go forward with NASA. This was an idea to develop an inflatable structure to attach to the ISS, the International Space Station. But what did happen is a private company called Bigelow Aerospace developed this, and they actually have 2 space stations on orbit right now using this technology. There's no people in this, but the point is that the technology is there already. This is not science fiction. Now, all of this depends on us confirming a lunar cave in the first place. And the Google Lunar X Prize team that I'm on, Team Hakuto, plans to do just that. So we have this dual rover architecture. We plan to tow a small rover to the edge of one of these skylights, drop it in on a tether. We can drive around, take some pictures, and confirm. And then we're really ready to take the next step and turn this into a structure. And this is just 1 or 2 years away. Now, I think the next step after this, we would have something like the International Space Station on the surface of the moon. I chose this image with the Canadian astronaut Chris Hadfield, not only because I'm Canadian, but because it shows that space can be really fun. And not only can we do science there, but eventually we can have something like on-orbit hotels and lunar hotels, which I think is very exciting. And once we have a permanent base to do some science, then we can really pick up steam and do something interesting. So some of you may have heard of asteroid mining. This is another thing that's not science fiction. So there's already several companies working on traveling to an asteroid to bring material back to the surface of the Earth. And actually, a Japanese spacecraft in 2010 successfully returned an asteroidal sample to the surface of the Earth. So we're already doing this. The problem with this approach here is that return is just a fraction of a gram. Not very useful for anything beyond science, although it was very, very cool. And I think an even better approach to this, instead of developing slowly some technology that can bring back grams and then kilograms and so on at a time, if we have a base on the moon, we can just go there and pick up asteroidal material. All those craters are caused by it, so there's lots of this material that we can just pick up. And furthermore, we can mine the lunar surface itself. There's a lot of interesting things there. For example, helium-3, titanium. We could even mine the materials needed to make rocket fuel. So this is really where I'm getting at with this image of a lunar launch pad. We have the ability to go to the moon, set up a base, and actually mine the rocket fuel right there. Now that's missing an important thing. So we measure the difficulty in getting from one place to another in space using something called delta V. The units are kilometers per second. The derivation doesn't really matter. I'm just using them as a comparison here. So you can see it's 18 of these units to go from the Earth to the moon to Mars. And this is kind of an idea of what I'm talking about. It's only 3 units to go from the moon to Mars. Unfortunately, or fortunately, depending on your point of view, it's easier to go directly from Earth to Mars. This shouldn't be very surprising. So what's the point? I really want to focus on this number here. I mentioned you can mine rocket fuel on the moon. That helps a little bit, but you still need to send a spacecraft to the moon, send a rocket to the moon, and then subsequently launch it somewhere else. Fortunately, we can 3D print those things. So titanium is a very useful material for making aerospace projects. That includes rockets, that includes spacecraft. And we can mine that on the surface of the moon. I think some of you here today saw examples of something like this. This is a 3D printed titanium structure. And this particular image is from the European Space Agency. So again, this is not science fiction. This is something that the European Space Agency is working on getting to the ISS in just 4 or 5 years. So this is already space-ready technology. So overall, I've mentioned that we've already found probable caves. We're just 1 or 2 years away from confirming one of these caves. We have the technology to turn it into a structure. Therefore, we have a scientific base possible on the moon within just a decade or so. That can turn into things like lunar hotels. Asteroid mining can be developed by going to the moon and testing technologies. But ultimately, my favorite point of all of this is we can develop the technology to build spacecraft, mine rocket fuel on the moon. Then we have a lunar launch pad. We can go from the moon to any other moon on the solar system, any other planet, and even beyond.